All right, we're starting over here. This is lesson 2.4, worksheet 6. I'd really appreciate it if we could get started here quickly. Yes, we have talked about the possible number of zeros a polynomial can have, and today we're going to look for all the zeros, not just the nice, pretty rational zeros, not just the real zeros. We're going to have to find all the zeros, okay? All right, before we go any further, could someone tell me what a rational number is?
All real numbers. Off our math, UK 14.
Anybody tell me what a rational number is?
Positive. It's all real numbers.
Rational means numbers that can be written as a ratio, which means numbers written as a fraction. So it can be negative, it can be positive, it can be a fraction, it can be a negative fraction. Non-repeating decimal. 1/3 is a fraction, so therefore 0.3 repeating works because it's equivalent, okay? Repeating decimals are fractions. The question was non-repeating. What do you mean by non-repeating?
Well, like if it, that's non-repeating. I mean, like they end.
Yes. Okay, a terminating decimal like 0.75 or 0.5 or 0.125, those are all fractions. Okay? Yes. The ones that are not rational numbers would be square root of 7. If you had something like 0.010010001, okay, something crazy like that. Pi, e, all those irrational numbers. All right. The rational zero theorem is important in helping us think about what numbers can work as rational zeros. It was far more important before graphing calculators because we had to try those numbers. Okay, you have a calculator to help with this, but there is a question on the quiz Thursday that says list all the possible rational zeros using this theorem. You did this, I think, last year. I'm not sure regular algebra 2 did. I think so. Okay. It says every rational zero of a polynomial function comes from the factors of the constant term over the factors of the leading coefficient. So this is what your paper says. Same thing. Okay. You find the factors of the constant and you put it over the factors of the leading coefficient. So let's do an example. What are the factors of -6? 1, 2, 3, and 6, right? That's it. And it's plus or minus all of those. The denominator is factors of the leading coefficient, which is just 1. So it doesn't change anything. So there are 2, 4, 6, 8 numbers there that we could try by synthetic division or by plugging them in to the actual function to see if we get a 0. We have graphing calculators, so it's much more efficient to graph and determine that -2 was a 0. So then we did synthetic division and got this. Do you remember this is a sad little depressed polynomial down here? Okay. The depressed polynomial does not factor further. Does that mean there are no more zeros? No, it means there are no rational zeros, okay, but there could be irrational or even imaginary zeros. We have to use the quadratic formula. If you have the program on your calculator, you may use it. I'm going to do it by hand, and some of you don't have it. You need to remember how to do it by hand. Opposite of b, plus or minus square root of b² minus 4ac all over 2a. So I have 7 plus or minus the square root of 61 over 2. Anybody else getting that? Someone else get that? Okay. So what were all of the zeros of this polynomial h of x? How many should it have? Degree 3. It should have 3. Anybody paying attention here? I feel like this is a pretty easy question and no one's getting where we're going here. What was a 0? We graphed it and found negative 2 was a 0. And then we found the other 2, which were okay. Now, they're going to come out nasty decimals if you find them on the calculator, right? If you did it by graphing, this is the only one that comes out rational or nice. These are irrational, and you have to be able to find those exactly on the quiz, okay? The irrational ones. You can use the program, but we had to find them using quadratic formula. All right. You do not have this, but you do have a question on the quiz that says find all the possible rational zeros. It doesn't mean they have to work, just list them. And how do you do that? All the factors of 36 over all the factors of 2. All right, I'm going to go with 2 first. What are the factors of 2?
1 and 2.
Okay, this is a little more painful, which is part of the reason I probably wouldn't pick this for the quiz. What are all the factors of 36?
1, 2, 3, 4, 6, 8, 9, 12, 14, 16, 18.
Okay, guys, when you got to 6, then they should have come in pairs, right? 4 times 9, 3 times 12, 2 times 18, and 1 times 36. Okay. Now, you will not get full credit for writing it like that. You don't have to write out plus or minus 1,000 times, but you do have to list them all. 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 9 over 1, 12 over 1, 18 over 1, and 36 over 1. But there's a few more. 1 over 2. 2 over 2 is already on there, right? Because it's 1. 3 over 2 isn't on our list yet. It's 3.
9 over 2, 12, 18.
Okay. So this is the complete list. Again, I wouldn't give you that one just because I don't want to have to grade all those. Let's try this one, though. What are the factors of the constant? 1, 3, 7, and 21. Yep. And the factors of the leading coefficients? So if we put them all over 1, we'd have 1, 3, 7, and 21. What else, though? 21/3 is 7. Do we have them all? Okay. That's a more manageable list that I could ask you to do on a test or quiz, okay? But you get that whole possible rational zeros thing. You could find those easily. All right. Here's the one you have on your worksheet. List all the possible rational zeros. The constant is 20 and the leading coefficient is 1. So they are what?
1, 2, 4, 5, 10.
Okay. It says then determine which, if any, are zeros. Back in the day, I would have had to plug those numbers in, or I would have had to do synthetic division to find if a remainder is 0. What's the most efficient way for you to do this?
Graph it.
Graph it. This is a pretty important and complex lesson today, so I hope everybody's paying attention. I'm a little worried some of you are doing some other stuff. Okay, anybody come up with some zeros? I didn't make a nice graph of it, but enough that I could test them. Do test them. Don't assume it looks like they cross at particular places, okay? Because, like, square root of 10 and 3 are really close together, and you won't be able to tell unless you try them. So once you have this, if you think negative 2 works, what should we do? Trace negative 2. Did it work? What else? 2 works and 5 works? Okay. We could have also looked at the table to check those, but the table wouldn't have given us any fractional ones. There can be nice fractional ones, right? Like 1.25 could be 1 and it would be a rational 0 still. All right. We were supposed to just list the zeros. So where were the zeros? Negative 2, 2, and 5. Later on today, it will ask us to write the linear factors on some problems. So we would have written x plus 2, x minus 2, and x minus 5 if it had asked for the factors. Everybody okay? All right. Moving on. The fundamental theorem of algebra says that when we have a polynomial of degree n, that there should be that many zeros. Okay? They're not all real and they're not all rational. But when you have an odd degree, so if we had this, does there have to be at least one real zero? What does the graph of that look like? Some goofy thing like this, right? It's odd. So does it have to cross the x-axis at least once? Okay. If you have an odd degree, there's going to be at least one real root. Okay. If you have an even degree, does there have to be? No. It doesn't have to be even one real zero. Okay. But if we can find imaginary zeros or over the complex number system, we can find all of the zeros. This one would have 5 or up to 5. There can be multiplicities, right? And this one would have 2. All right. What we just talked about, though, helps us to understand why this is true. Zeros come in conjugate pairs if you have complex zeros. So if negative 3i is a 0, positive 3i has to be a 0 as well. Because it had to be a factor like, what would that be? Plus 9? Does that work? Yeah. If this was equal to 0, you square root both sides, plus or minus 3i. Okay. So they have to come in conjugate pairs. So if 2 minus 7i is a 0, what else has to be a 0? All right. This example demonstrates this. It says if we write a polynomial function of least degree with real coefficients that has a 0 at 0 and 1 at square root at 2i, and the I is not under the radical. Okay? If you know you have a 0 at 0 and the square root at 2 times I, you already know you have one more where? Negative square root of 2 times I. Now, if I wrote those out as linear factors, and then I FOILed them together, what would I get back here? X squared, and then I'd have minus 2i square root of 2ix and positive square root of 2ix, right? So those would cancel out. But when I did this one times this one, I'd get negative 2, because square root of 2 times square root of 2 is 2. I times I is I squared. And that would become x squared plus 2. Good. Now, we lost one. What was this one out front here? There was also an x, right? X minus 0 is just x. You can leave it in factored form as far as I'm concerned today. The book will always do standard form. My rule is just you cannot leave it with imaginary coefficients or irrational coefficients. But if you got this far, there's no reason on this question not to finish, right? But we're going to see some where you don't want to keep foiling because you'll be here all day. All right. I'm going to do this one 2 different ways. And I'm going to teach you a trick. And it's not on your notes, so you're going to want to make a note of this in a minute. All right, it says find all complex zeros of this lovely polynomial given that 2 plus I is a 0. All right, if 2 plus I is a 0, what else has to be a 0? Okay. Now, back up for a second. If you knew 7 and -3 were zeros, the factors would be x minus 7 and x minus -3 or plus 3, right? It's the opposite. It's x minus. So, the factors here are x minus 2 plus I and x minus 2 minus I. If I distribute those negatives, I get x minus 2 minus I and x minus 2 plus I. I wouldn't bother to write this down if I were you because I'm going to show you a shortcut. Okay? Then you would have to distribute all this. Help me. Multiply an x through this second parenthesis. So I'd get minus 2x plus ix. Now distribute the -2 through this second parenthesis. Okay? And finally distribute the -I through this second parenthesis. Minus I squared, right. Okay. Now what happens? Thankfully, ix and 2I go away. And a minus I squared is really what? Plus 1. Minus a -1, which is plus 1, yes? All right, so what does this simplify down to? We have an x squared minus 4x plus 5. Okay, now I'm going to show you a shortcut. Ready? When you factored something like this, since you first learned to factor in Algebra 1, how did you factor that? Okay. These two numbers right here had to do what? They had to multiply to make this number, right? That's called the product, yes? Okay. That number at the back had to be the product. Okay. Then they also had to do what here? Add to that. Now be a little bit careful. The solution to this is what? If we set it equal to 0. This is a positive 9 and this is a -1. Do those add up to be -8 right here? No, it's the opposite, okay? So adding up is called the sum, and it's going to be the opposite of the sum. Okay, it's x squared minus the sum times x plus the product. That's the rule. Write that down somewhere. X squared minus the sum of the zeros plus the product. If we know that, we don't have to do the crazy foiling that we just did, that I just did. Yes. What were the 2 zeros on the problem we were doing? 2 plus I and 2 minus I? Okay. If I told you to add those, what would you get? If I told you to multiply those, you would get 4 minus I squared, which is 5. That's the product. So it should be x squared minus the sum times x plus the product. Is that what we got when we FOILed them together right here? Was that way faster than FOILing them together? All right. So the factor we came up with was x squared minus 4x plus 5. Do you want me to write that out on here, the sum part, just so I can erase this and we could write down how we got it a little bit shorter, but you had some work then. So we did 2 plus I plus 2 minus I and got 4 was the sum. And then 2 plus I times 2 minus I gave us 4 minus I squared, or 5, as the product. And then we plug those in there to get that factor. Does that help a little bit? All right. Now, it painfully, very painfully, says use long division to find the remaining factors. You can just graph it, okay? I'm going to do long division because I want to review it one more time. If you don't have room and don't want to write it down, just talk me through it, guys. We have an x squared minus 4x plus 5, and we're dividing it into this original polynomial up here, x to the 4th minus 5x cubed plus 3x squared plus 19x minus 30. Whoops. All right, just a minute, I got a little messy there. Please talk me through this. X squared to x to the 4th, I need to multiply by what? X squared. Can you distribute that through this whole thing for me? Okay, and then remember we're subtracting each piece there. So we end up with a negative 1x cubed minus 2x squared. I think I did that right. Okay, now what? To get a negative 1x cubed, we'd have to multiply this by negative 1x, or just a negative x. Cubed plus 4x squared minus 5x. Change the signs and add. Or that's what I like to do anyway. Negative 6x squared plus 24x minus 30, which hopefully goes in exactly negative 6 times. Negative 6x squared plus 24x minus 30. Okay? It was supposed to be a factor because they told us it was a factor, so it should have come out 0, and it did. So if we had this as our remainder, x squared minus 4x plus 5 with a an additional factor of x squared minus x minus 6. That's our original polynomial. This does not factor nicely because it has these two zeros. Does this factor nicely? X minus 3 and x plus 2. So could we have found the additional zeros by just graphing 3 and negative 2? All right. When it says you must write as linear factors, and there's one question on the quiz that says you must write as linear factors, that means you have to have only a power of x. You can't have any x squareds. So they wrote this, and you can leave it with those parentheses. I don't care. This, and what are the other two? X minus 3 and x plus 2. Okay. If it didn't say linear, the next slide is going to say irreducible quadratics. Then you could have left this, because that is irreducible quadratic right there, okay? All right, crazy business, I know. Got a couple more here. I, of course, am a crazy math teacher and think these are kind of fun, but we're going to practice this one more time, and then we're going to do the kind where you start at the beginning. These are kind of working backwards to find the polynomial. What are the zeros they give us? Be careful. The commas mean they're separate zeros. 4 plus I, which means this and this have to be zeros, right? Got to be conjugate pairs. Okay. So before we do anything else, how about we do the sum and product business? Will that help us? What is 4 plus I plus a 4 minus I? Okay. And a 4 plus I times a 4 minus I? I got 17, yes? Okay. It says write a polynomial function of least degree with real coefficients. The book will say in standard form. The little stars are from Hofbauer. They say as long as you have integer coefficients, meaning you can't have i's or square roots, then factored form is fine with me. Okay, so can anybody tell me, this would be the linear factor, x minus 4 plus I. X minus 4 minus I. X minus negative 4 and x minus 1. Okay. You can leave these two because they have integer factors. Anybody remember the shortcut? What's going to happen if we do all that? We found our answers over here. How does it go? X squared, opposite of the sum, plus the product. Max, you got that? You awake? Not drooling on your notes, are you? Okay. What about Derek? All right. The book, guys, would continue to FOIL this all together until they got an x to the 4th, x cubed, blah, 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 blah. I'm good with leaving it like this. All right, here we go. The directions for the rest of these say you need to find as a product of linear factors or irreducible quadratic factors with real coefficients. Irreducible just means you can't factor it any further with real numbers. All right. If we had to find all the possible rational zeros of this, we'd have to find all the factors of what? 216. Does that sound fun? Not so much. But we're going to start by graphing and finding some of the real zeros. See what you can start with. I'm not going to do it on the online one because it takes forever for me to type it in, but can you type it on your calculator and see if you can find some of the rational ones? Find some nice zeros. Remember to test them once you find them, because just because they look nice aren't always right. I'm only seeing 2 between negative 10 and 10. Anybody see 2?
Yep.
What do you see? Okay, if I go trace 4, enter, it does work, and negative 6 works, okay? So graphing found a 0 at negative 6 and positive 4. Okay, the other 2 aren't showing up. They could be out further. I'm just thinking they're imaginary. So, anybody remember what we did yesterday? We can do synthetic, yep. I'm going to do -6 first. Doesn't matter which one we do first. 1, 2, no placeholders, right? Might need a calculator. These are getting big. Bring down the 1, multiply, add, multiply, add, multiply, add. I'm gonna go with 216. Anybody checking? 6 times 18 is 216. Should come out 0 if it was a 0, right? Did I do something wrong?
9 plus 6, 54.
Yep.
It looks like.
Is it -36 then? And then it's 216? I was just checking if you were awake. Nothing like making a YouTube video with stupid teacher mistakes in it, right? Okay.
That's why they have editing.
Yeah, well, I'll just leave it. I don't care. No one is going to watch it except Josiah and Trey, and they're probably both asleep by now if they put it on. Yeah. All right, guys. What do we do next? We have to do 4, but be careful. Do we go back to the original polynomial? We use this depressed polynomial here, this poor little sad, anxious polynomial, because we want to get down to a squared if we can. So bring down 1. Oh my goodness, that was a lot easier. Okay, what are the leftovers this time? X squared plus 0x plus 9. Okay, what were the 2 factors we did so far? X plus 6 and x minus 4. In any order, is that now a product of irreducible factors? What does x squared plus 9 factor as? It does?
Nope.
It's irrational. Plus 3.
The sum of perfect squares does not factor. If it was x squared minus 9, then it would factor. Okay, it does not factor further, so this is 2 linear factors and an irreducible quadratic. Okay? Now, I don't understand why they put this b before c. I can't list the linear factors until I've found the zeros. That makes no sense to me. I need to find the zeros here. How does this solve if I set it equal to 0?
X squared is -9, square root of that, you get 3i. Plus minus 3.
Okay, so for part C, this was part A. Part C, the zeros are, be careful, there should be 4 of them. 3i, -3i, -6, and 4 in any order. Okay, but part B is list the linear factors. Anybody know what that's going to look like? 2 of them are x plus 6 and x minus 4.
X squared plus 9.
It's not a linear factor if it has an x squared in it. It's a quadratic factor. So we just need to write it as x minus 3i and x plus 3i. Linear factors means you can only have powers x to the first. It doesn't have to have nice coefficients because you can't make it have nice coefficients. All right, one more. Somebody graph this bad boy and find us some zeros. There's not very many nice ones, but I think we can find a couple that we can work with here. Okay, I think there's a nice one at
Yeah.
-3.
And then there's
But find that one between -2 and -1. Can you calculate a 0 between -2 and -1? Because it does come out rational, right? -1.25 is rational. In other words, it's ending, and we could write it as -5/4. Actually, the fraction is easier when you do the synthetic division, but you can do it whichever way you want. Which synthetic division do you want to do first?
Let's go 3.
Okay, -3, we have 4, -15, 43, 577, and 615. Nice. Okay. -12, -27, 81, 124, -372. I'm making these up as I go. They're probably wrong. 205, -615. I think it worked. Okay. I'm going to use the fraction because what is 4 times -5/4 going to be? Just -5. Add is -32. Okay, which if I divide it by 4 is -8 times 5 is 40. I did that right? 164 divided by 4 would be 41 times -5 is -205. I think that's right. Okay, is this an irreducible quadratic? Keep going. A little bigger. 4. We can take a 4 out of all of this. X squared minus 8x plus 141. Now does it factor further? Factors of 41 are 1 and 41. I don't think that's going to get us very far, right? Okay, let's go back and do what we're supposed to do here. A says product of linear and irreducible quadratic factors. I don't care if you put that 4 out in front of your x plus 3 and your x plus 1.25 and your x squared minus 8x plus 41. Does anybody know what might be just a little bit nicer to do with that 4? If we distribute it to this one, we'll have an x plus 3 and a 4x plus 5. Whoops, I don't know how that came at 4. All right, so that's A. I have to do C next because I don't know how to do B until I've done C. What are the zeros at, guys? -3, -5/4. Oh, I don't know what just happened to my... -5/4. I don't know what happened right there. And guess what we get to do? Doesn't factor. Quadratic. Okay, you have a program. You go to Program, Enter, and then what are the A, B, and C, guys? 1, -8, and 41. I think I can even do that. It won't show up on my computer, will it? And that's where it's got to be. Okay. I can't tape it, so. 64 minus 4 times 1 times 44. Is it -100? That's a 41. Isn't it 8 plus or minus the square root of -100 over 2? Which is 8 plus or minus 10i over 2, which is 4 plus or minus 5i. Don't kill any kittens. You got to reduce both of them, right?
My calculator gave me 8 plus minus 10 square root of -1 over 2.
What's the square root of -1? I.
Oh.
Right?
Yeah.
Hit enter again. One more time. Does it say 4 plus or minus 5i?
Yes.
Yep. Just gotta keep going, okay? So we ended up with 4 plus or minus 5i for the other two zeros. Okay, last thing before we all fall asleep. D, right, or C, B. Oh my goodness. I know my alphabet. B. Whatever that other letter is. B, we gotta write linear factors. One of them was x plus 3, and the nicer one of the other was 4x plus 5. But now how are we going to write this? You have to write x minus, what is one of the zeros? 4 plus 5i, and x minus 4 minus 5i. Now if you want to distribute the negative and get rid of those inner parentheses, I'm fine with it, but you can also leave it like that. I don't care. All right, you want to try one off the homework together? All right, here's your homework assignment, and every problem assigned except number 2 is odd. So you got some help in the back of the book, okay? But the back of the book will give you standard form